And we should be live. Welcome everyone, happy new year, health and success also here on our main channel. So let's start in 2021, obviously making our tiny little T2 just raw vanilla Linux even more amazing. Obviously, what would be better than stealing others' artworks work? And that would be Clear Linux, right? Intel's Clear Linux. Have you tried Intel's Clear Linux? Actually, I tried it the last days, wasn't the most impressed. However, also super hilarious, right? Decades later, Intel of all companies needs to create the 1612 Linux distribution, but whatever. Anyway, let's, obviously nobody would really want to use it, right? Let's at least make good use of their work and copy obviously their performance work. And long story short, I hope you stay tuned. However, because I was wondering, in some news outlet benchmarks, Intel Clear Linux sometimes comes sometimes a little bit ahead. And I was wondering, why are not more distributions copying their stuff if it's so much better? And actually, what the freaking heck are their magic secrets? And I started with the kernel patches because we have seen here our smart optimization or other just recompiling everything for AMD Zen version 2 or something. Certainly makes the performance difference, but still, when I compared Intel Clear Linux the other days, it was sometimes a little bit faster than T2, and obviously can't live with that, right? So it will take some time, and spoiler alert, I couldn't really make it that much faster. However, so anyway, I hope you watch a little bit longer because I have some more details to share. So this latest builds of this morning, and you see working at night, obviously, here on our Linux and YouTube channel. And the build time, I used the Linux kernel, like building a new Linux kernel and then using this as a benchmark, because that is what we usually do here, compiling source, Rust, Cargo, Firefox, and you name it. In the Linux kernel, obviously every other day for the latest and greatest security and performance patches. So I benchmarked basically compiling the Linux kernel, which on this AMD 5950X with all modular is configured and stuff with T2 takes 6.5 seconds or 6.66666 seconds. And spoiler alert, unfortunately, just importing their patches didn't really make a difference. So I can't, like, this is like basically even, it's maybe even 1.1133 something faster. So it's in the measuring accuracy. And so probably also another lesson, theoretically, probably I should disable performance boosting and compile with a stable all core clock, because otherwise we are measuring here the differences in cooling, thermals, turbo boosting, and all this fun stuff. So this is really set. However, don't tune out yet. I will go through the patches, see what they actually have there. I will also commit some of them. Some of the patches are actually somewhat usable. Also, as this numbers shows, this patches alone do not do everything. Fun fact, as far as I've seen, they compile the Linux kernel with NUMA, for example, non-unified memory architecture for multi-socket systems, which is not used in this Ryzen. So I would think the T2 kernel, I tried this yesterday, it didn't make much of a performance difference. I would think my kernel should theoretically maybe a tiny percentage faster, like 1% or 0.5%, due to not having all the NUMA code in there for supporting non-unified memory architecture stuff. So anyway, so this will continue. But anyway, I found some major things that are nice to have, but more in a second. So these are the patches here on GitHub Clear Linux packages Linux. And as so often here, a nice patch series numerically sorted. And I mean, some of the stuff I also really wonder, recurring critique, what are these big companies thinking of? Yeah, thanks for having this here privately. Why is this not in upstream Linux? How old is it? Even August, also not super old. But so this is scheduler fair, ignore cache hotness for SMT migration, and so SMT symlinks share caches, so cache hotness should be irrelevant for cross-sibling migration. So this is just if this SD flex here, SD shared CPU capacity, then return 0. Super tiny patch. Maybe it's like, yeah, I can't measure a difference. Theoretically, it could make a tiny little bit like 0.001%. I mean, it's this kind of stuff. This is what is it doing? It's in the scheduler of processes of deciding what to run next and stuff. And obviously with hundreds of processes like Pulse Audio and Firefox and GCC and all the fun stuff. Anyway, tiny little thing. However, I wonder if this is a good thing. Why the freaking heck is it not upstream? But yeah. Anyway, some of this stuff is just error versus info. This stuff I've not even copied over. For me, this is worthless. I also wonder why. Also, probably maybe they saw this scrolling there. Maybe they were booting on some MacBook or ThinkPad or Dell XPS or even worse like a Razer, whatever, with garbage BIOSes and whatnot. And maybe some Intel developer was fed up with having these messages. So this is just demoting some print stuff from error to info, probably not to see it on otherwise black boot screens. Like, yeah, I didn't even bother copying this. I copied this here. So package Linux, also best without typo. So all of this stuff I copied and I'm currently running this, which is like half of the patches. This increase X4, I think, so this I didn't, also yeah, tiny little tuning, right? JBD, this journaling block device stuff to default max commit age, like 5 to, is it seconds or something? Commit disk after X seconds, so it's like, yeah, from 5 to 30 seconds. Actually, I've done stuff like this already. Intel not new, I've done stuff like this on Rock Linux, laptop mode stuff, 2005 or something, with Riser 3. It was probably even a mount option, right? Was it not commit equals 30 or something? I've done that 2005. Didn't even, I'm not running X4, didn't commit this or whatever. Silence RAPL, this is also just some error versus info. It's like, nah, I wonder that Intel even bothers with this. It's just loading the PowerCap driver on AMD. Doesn't support that CPU family. It's like, yeah, whatever. Didn't bother. I wonder that Intel people even, for maybe the sake of not having any boot messages, bother with it. It's whatever. Reduce wake up on PME checks. Workaround miswired boards, sadly too many of them, like as I just mentioned, right? Amazing BIOSes, including my own, right? In previous video, ASUS BIOS update last, since everything past 1301 or whatever that was, I get here this stupid common interrupt, no IRQ handler for vector. It's like, yeah, thank you very much, ASUS, thanks for nothing. Previous video, it wasn't there in the original BIOS 1303 or whatever that was, but everything, all the 6, 8, 7, 10, 9, whatever BIOS instance, and yeah, they produce this amazing warning or whatever is going on there. But yeah, amazing BIOSes. So it just like PME timeout of whatever. I think I might have even copied that just for the sake of it. PME wake up. I copied this because I thought maybe if I'm affected, maybe this also, yeah, probably not much, but whatever. KSM, this is kernel shared memory for sharing memory, for example, between virtual machines. So this is scanning the memory and unifying those page mappings. For example, if you fire up 10, 20 virtual machine stuff and they all run the same kernel, glibc and stuff, theoretically, they are huge savings potentially. And this is it Watchdog? I'm also wondering why is this touching Watchdog, not entirely sure, but whatever. So this is, I think I copied this, but yeah. Intel idle tweak CPU idle. So this is this kind of stuff. Why is it not upstream? If this is, I copied this, I think I'm probably not running this driver. Maybe this is Intel only, not sure if this applies to AMD. Just here some target threshold stuff. I've seen other gaming patches do similar kind of stuff. So yeah, if this is a good thing, why is it not upstream? But yeah, maybe it doesn't even affect me, but whatever. Just to in summary of what are these magic patches of big companies doing. Boot stats, yeah, I don't even bother with boot stats, so didn't take this super tiny stuff, just some print, who cares? I mean, I certainly don't. SMP boot reduced timer. So this is like not recalibrating the timestamp counter, high frequency clock, or actually probably the clock of the main clock of the CPU counter. So not recalibrate on non-boot CPUs. So there's like no point of recalibrating. 200 millisecond plus of boot timer. Certainly I take that. I copied that maybe. So I also wonder, I benchmarked this. Also this is only boot time, right? This is not runtime benchmarking. Certainly nice, somewhat nice to have. Also personally couldn't care much about 200 milliseconds of boot time. But I also wonder which of those, if I take from all distributions all the best patches, then I end up with 100 patches in T2. That is a little bit, I like it more raw, like sushi and vanilla and stuff, and not like patched to death like some major companies apparently do. So I'm wondering what of this stuff even to take. Maybe I commit the 5 best patches of this, because yeah, not much of a difference. This is initialize ATA before graphics. So ATA init, so for your storage stuff. Init is a long pole in the boot process, and it's asynchronous. Move that graphic init after that, and so that the ATA and graphic initializes in parallel. So again, cutting boot time a little bit depending on how many stuff. So this is just reordering the linking stuff here. And as you see, as the order this stuff is linked together determines the initialization order at boot time, at runtime. So this is just moving the stuff down, so below all the power ports, SCSI, NVMe. Again, only boot time. I took this, I mean, the stuff boots. Well, the longest boot time in my boot time is anyway entering the full disk encryption password. But anyway, I took this just for the sake of it. This is trust hardware random more. The tinfoil hat, as Senior tried to credit the random instruction here, more VMs, because VMs, but even maybe modern hardware, super stuffed on entropy, random data stuff from keyboard and network and stuff. So while we can wear a tinfoil hat, like also hard to argue that some random stuff is better than zero entropy. Again, doesn't affect performance. I took it over because yeah, I wear enough tinfoil, aluminum foil hat, but yeah, probably for our virtual machine stuff, nice to have or something. Again, and so we go through all the patches. You see all the stuff, not even major runtime stuff. What else do you have? Random. So you see, just quickly talking about stuff takes some time. So this is IPv4 TCP allow, the memory tuning. So this is tuning TCP, IPv4 TCP stuff from 4 and 6 to 16. Memory max. Actually, I wonder if this helps with our buffer upload here and stuff. I think I took this over. Yeah, this is tuning for TCP to go. Again, does, if anything, affects database performance or something, not our Linux kernel compile. I also wonder if this is potentially also buffer upload, right? Maybe I should also make a dedicated video about buffer upload and how it ruins the modern internet. I wonder why this is not more default. Also, maybe on the embedded systems, maybe they sometimes don't have as much memory or something. But yeah, this here is a little bit strange. I copied this. I didn't quite. Oh, wait a second. This is not true. What is it? Print fsync count. Wait. This is some boot chart stuff. Nonsense. I didn't take this over because I'm not interested in boot chart stuff. Boot option to allow unsigned. Yeah, also we don't sign cryptographically signed modules, so I didn't take that. Boot option allow something. Again, everything not performance. This is also a super tiny thing. You have seen previous videos. I sometimes need to patch patches here, and yeah, Intel obviously needs to do this. I'm actually surprised that this is. I didn't even know that the etc firmware is a thing, or flip firmware updates. But actually, maybe I should actually patch them all out. There's no point in T2 to try this even. But yeah, do we patch passes in Firefox, Sandbox and stuff? And Intel does as well, in case people were wondering that our stuff is some unprofessional hobby stuff. Stateless firmware, migrate some systemd stuff. I think I didn't take this over. This is just some, yeah, Bond default max, but it's like, yeah, YOLO, whatever. You had me at systemd. whatever this stuff is, not for me. Alan Cox there of Audit Intel KVM tool, what is that even? Extended attributes, I have no idea, something, whatever, slightly over paranoid, whatever. Didn't copy this, I'm not interested in it. And also you see what kind of strange stuff like extended attribute, why do they need to patch this? Maybe I should actually, by the way, maybe I should actually, that I review this, I thought this is turbo boosting. I think this is actually, I skipped a little bit over this. I thought this is some Intel Turbo Boosting 3. Only now did I see, this is just a scheduler. Actually, this could make a major difference. So much to, oops, thank you very much, cut and paste in the year of the Linux desktop. So much to reviewing this at midnight and only on your YouTube live stream, realizing this is some generic scheduler patching. Best score, second best score, best core score, yeah. Oops, did I? Oh, this is. So this is tuning the scheduler. I should have looked more closely. This could actually, this kind of stuff could easily make a percentage or two difference. So much to need to retest this. Probably should. So much to, naming. I actually skipped a little bit over this because I thought there was some Intel Turbo Boosting for latest generation Intel CPUs, but yeah. So this is really mysterious stuff. So I have no idea why they do this. This is some VDSO, I think, patching here of rep. So this is, I thought they use this for patching. Rep knob pause is a good thing to insert into busy wait loops. So they replace this repeat knob thing pause. Complex instructions and architecture, right? Previous video, Intel's amazing ISA. So this LFence is super old, available since Pentium 4, I think, so like 15 years ago. I don't know why they do this. Maybe it's slightly better, but if it's slightly better, why is it not upstream? Although probably it needs a conditional of building for Pentium 4 or later or something. So probably this could be also, yeah, super unclean, right? Not very professional. This should be at least if configuration support that, because again, Pentium 4 and later. I took this over, I think. Also, yeah, usually raw like Sushi and Manila, except if you take every other distribution, best patches. Scheduler 2, yeah, so I built with this, again, don't see quite a difference. Maybe it's tiny little bit better for something, but again, why do the Intel also, this Adrian van der Veen is a long-term Linux contributor. Why is it not upstream? If it's better, I don't know. Do accept cache efficiency here, last in, first out or something. I think I built with that, do accept, yeah, so we built with that, again, if it's better, not for my workload. So this is again just tiny bit, little bit tweaking here. Also, yes, okay, socket. Maybe this is mostly apparently for network, which probably might accept, obviously, why this is not really affecting my workload. Locking. Read-write semaphore spin faster. So I thought maybe this is a potential, because this is like read-write semaphore owner spinning a bit. So this is, instead of when spin on owner, instead of CPU relax, do that less often, like as the subject says, do this semaphore spinning faster and only CPU relax every 1,000 times, so like 999. I guess that probably should be 999 times of 1,000, like 1 per mil, only CPU relaxing here. Theoretically, probably could, like, yeah, it's spinning obviously more, CPU relaxing less. You wonder if this is just some, like, certainly if this would be a good thing, it would be upstream. Maybe this is just some benchmark tweaking of like kind of fake stuff of it could probably hurt some busy workloads, I guess, because it's wasting more time spinning on that. Again, my workload compiling current. So probably this, I probably don't bother committing in T2. Maybe here's some init order for better boot performance, but this kind of stuff, it's like, yeah, if it's just a hack and not upstream, then just to give you a summary of reviewing Intel's Clear Linux magic, this is changing libahci for your Serial ATA stuff to ignore firmware stage, spin up flags and user. So I think this is only spinning drives up differently. I think I did not even take it over. No, I didn't. This is probably no idea. Maybe I don't know what's up with it. Probably I guess that only changes boot timing, but yeah. This is also only cosmetic. Print CPU number in if something crashes and you see in your system log segmentation fault at something, and print the CPU processor ID. It's like no idea why, purely cosmetic. Don't really need this. Only if you overclock like we do here, like maybe to see which core segmentation faults the most and you need to overclock less or something, I don't know. Microcode stuff I didn't patch. It's like, yeah, going to stop machine, print K here. Microcode patching is like force update is the same. Actually, wait a second, why do they do this? Force update microcode even if the revision is the same? So, whatever. Not the most into microcode updating anyway. So you'll whatever. Echo reload to force load. So does it want to force? If you want to force uload to load, even if it's a version normal upgrade. So this is similar. No idea why. And maybe when the Intel people internally have multiple versions of the microcode for testing with the same revision and say because. So I would probably say normal end users don't need this. It doesn't make much sense to be in a Linux distribution, in a public Linux distribution anyway, in my opinion, or whatever. In any case, not the most interesting. Fix bug. Ucode is like, yeah, fixing bug there because can't compare revisions properly enough. Not interesting. NVMe. So this is some NVMe. I think I took it over. This is just changing some default maximum latency in microseconds thing. I have no idea. I never had an NVMe problem. So also, yeah, professional patches, right? It would be super amazing if they would put there a line of what the freaking heck hardware is even affected, because I never had a problem. I anyway took it over just for the testing, but I don't commit this stuff. If I don't see a difference, if it doesn't happen for me, then whatever. Would more trust the upstream developers and don't report an error if power clamp run on another CPU. So just checking if AMD then not support AMD CPU. So all in all, for the most part, not the most interesting. And due to that, you see I copied quite some stuff. Some stuff we can obviously delete now because NTP wake ups, or maybe this is not, did I even review that? 10 seconds of, I'm not even sure if that happens so much with it. So I actually, honestly, if this is a super rare thing, so this, probably not this, probably not this. Did I NTP, scheduler fake, no cache. So this is probably not the worst thing to do, PCI PME wake ups. I think I don't have that really. KSM workups, like also actually KSM I sometimes, is it even enabled by default or do you need to enable that maybe? Honestly, I rather, again, I don't measure a difference here. For me, it's only more maintenance burden and cluttering our stuff with making main package harder with each new version. Reuse timer calibration as I did before. So this stuff is more, 200 milliseconds or something of booting, but anyway. Elephant, so this stuff, again, I could keep it as long as it applies. Who knows if it's much better or not, actually, but also I probably should patch this to only apply for AMD 64 and not for our precious 486 builds. For cache efficiency, this could maybe tiny little bit of massive network connections. This probably not, and did I already that? Yeah, I mean, this still leaves so scheduler, fair ignore cache. This probably should be quite good. Intel tweak CPU idle C states. Not sure if this affects us on AMD. SMP boot initialize. Honestly, it's getting just a little bit. You know what? I think I delete this because I really don't want to have that much stuff here. I mean, this still leaves some patches, and because this was not really measurable a difference, I even changed, because this is my portable SSD here that I usually use, I even did the extra effort and built the last kernel with Zen version 2 optimization, and even that is not a measurable difference for compiling the kernel. Obviously, this spends most of the time in user space, as it should be, because you want to actually get work done and not waste time, your precious CPU cycles, in the kernel of doing management stuff. Basically, the less management stuff you do, the better. And so the less time you spend on the kernel, the better. So I even built with Zen version 2 optimization. Even that doesn't show a difference. I could try two more things. One is I'm building with smart optimization, which is building everything with size optimized except a few things that are hot. I could try a fixed speed optimization, makes a difference. And last but not least, I could rebuild for the scheduler turbo 3 patch here that I previously ignored last night due to misinterpreting that. Anyway, so this as a kernel patch is not too much secret sauce as far as I've seen here. If this is all they are running, you never know what. I actually was surprised I installed this Intel Linux stuff first in a VM and then booted this even natively here on this AMD 5950X, and I was surprised that on the system, I mean, first of all, I don't see a point of, I see a point of like Red Hat or SUSE or Debian, if not our T2 Linux, having a 1612 Intel Clear Linux stuff. It's like, nah, what is the point? In my opinion, Intel's effort would be better spent making Intel graphics and Linux kernel stuff or whatever open source better, but not doing another pointless distribution of, yeah, sure, some benchmarks is faster. So I wonder, maybe because similar to I built here even usually for Core 2 to be able to plug my SSD into everything you have seen in previous videos, I over-optimized the last T2 releases like for AVX1, and then people are like, yeah, but I have an old CPU to try it with, and I built with just whatever that was, and like Sandy Bridge or something for whatever that was, and even then people complained, but yeah, my old system. So now I'm with T2 even back our source distribution here to build with the very first Intel Nehalem or Nakona, but however not using their bloody scheduler stuff. So that instruction set, this is SSE3 I think, and scheduler tuning optimized like instruction scheduling for Zen version 2 I think, because now why not? And the problem is, I say this because that is a problem, and why I said previously, wouldn't it be amazing to just in time compile your whole, or just ahead of time compile your Linux, because that is exactly the problem with T2, but even more so Debian and Fedora and SUSE and stuff, because they compile once and you run it everywhere, so that you don't get the most optimization. And maybe this Intel Linux stuff is also that much faster, because similar to our, we just require an AVX CPU. Sure, that binaries make this run faster if you have a new enough CPU. The problem is, as per previous videos in summary, you don't need to compile everything. So the problem is you need this latest CPU and it doesn't run old stuff. This is why I actually would think a whole Java on steroids, like ahead and just in time compiled stuff, similar to Transmeta's code morphing of just code morphing that for your system, obviously permanently caching that for the next boot and stuff. But the one other thing you can do, and I will probably continue to look into Clear Linux another week or months, certainly not this week, I have other stuff to do, but I still wonder why is this stuff faster, and I will keep analyzing that and trying to uncover and find their secrets. And one thing we could of course do, I'm not the biggest fan of, we could build some core libraries like glibc twice for this per machine directory. We have this lib64 and then Haswell and SSE and AVX and stuff. So theoretically to improve out of the box experience, although I don't like it the most because this not only doubles and triples installation space and install media size, but it also doubled and triples my build time, because then I need to add special code in our build scripts to build libraries multiple times and have a list of that optimization things, so that glibc or other core libraries are built 3 times for this AVX2, AVX and SSE or whatever, which is why recurring theme, I would think, just and or ahead of time compiled stuff would be beneficial. Anyway, yeah, I wish I would have more amazing news. Maybe it shines better for other benchmarks than this kernel compiled stuff. Maybe this kernel compiled stuff. Also, I'm already taking the file system out of this. We are building in tempfs usually here. And I think I checked this last night. Yeah, we built in a 24 gig and 2 million inodes tempfs. But yeah, at least for this, it doesn't make much of a difference, but I will do at least 2 more tests, O2 and the Scheduler Turbo 3 thing. I only wonder why this stuff is not more upstream. What is it even doing? So this is best core and second best core of SMT priority. Fair, whatever, something. Yeah. If this is amazing, I wonder why it's not upstream. But anyway, so yeah, welcome everyone. Happy New Year. I hope you learned something, especially that just rebuilding the kernel, even if you spend significant hours of peeling out others people's patches and redoing that and benchmarking, you don't necessarily always find something instantly, and this kind of performance work and tuning takes significant of time. And the American wrote this IQ handler vector error he also gets since Agesa 1100 BIOS as well. It's like, yeah, super annoying. I really wonder what the BIOS vendors are thinking. I'm not sure. Maybe I would not necessarily think it's Agesa. I would think it's the surrounding BIOS bits. I would think the Agesa is only other early CPU enablement thing, but I could be wrong. There's also the problem of this closed blob, binary blob thing of stuff where you don't see that much and need significant reverse engineering, and why I would think this, especially this hardware driver and early boot firmware enablement, should be open source for people to review and actually fix. But yeah, anyway, that's it for that. This kind of more quality work hopefully to come. Again, today not the most to show. This is also, you spend hours, you think, hey, this will make things 5% more amazing, and at the end it's like, yeah, can't measure that. But this is also live, and as soon as we find more amazing stuff, I will publish more findings. But right, I also wanted to say, as the things, so also obviously the patches are not only one thing, it's also the config. So I also, their config is here. I hope this config fragment is probably what they send, what they said, and the config file is probably what the Linux kernel of additional stuff of all the other symbols they're not the most interested in generates. I downloaded that here. You see here Clear Linux OS Intel architecture stuff. And so this is still different. I didn't copy the whole config because it doesn't make sense for me. One thing, by the way, that could still make a performance change, I wonder if I should try with that actually. This read, copy, update stuff here, which you only get if you set CU expert. So this could maybe bring a performance bit or two, but but I probably have to try actually. So The reason, also yeah, slop debug, they comment out. The problem is the slop debug I probably can't set. I tried to set this, it doesn't set for me. Maybe I need to enable expert options or something. And so some of the stuff still differs. It's like, yeah, we still build support with Centaur and stuff, VIA and so on. It doesn't make sense for me to copy all their config because some of the stuff is also just more drivers. Also, my stuff is more modular. Like IPv6, I like to have most of the stuff. This is the reason why it doesn't make sense for me to just copy all of this stuff verbatim. However, I found some, at least the one good thing of some patches at least, but also I even tried with this Hertz 1000. I also tried with NUMA. Again, non-uniform memory stuff doesn't apply to Ryzen, maybe for EPIC. And I would think not building your stuff with NUMA, non-unified, if you don't need this, it should probably only cost a little bit performance because of extra kernel housekeeping structure stuff. So I tried with it wasn't faster, I commented it out again. However, here are a couple of more things that made sense, obviously not MIPS. Here that is some Octane work in progress, PowerPC obviously, and P3 stuff, RISC-V, where is it? So, so some NVMe, I tried even with that NVMe, so this is just some stuff. So some stuff I found like, yeah, probably nobody needs this, but let's enable that. However, there's one thing, maybe this checkpoint restore is nice to have, and IRQ time accounting, I thought, yeah, maybe. Also this, allegedly the scheduler auto group could make a performance difference, but again, in my case, can't really measure that. So this kind of options like probably nice to have, also, yeah, if you can measure that. Power cap, hypervisor, guess some. So some nice stuff. This is why 10,000 config options, not making this stuff up. Word count less, kconfig, also here. Also I wanted word count. 9,000 lines of config options, so not nearly 10,000. Sure, with some comments maybe. Are there comments inside? Yeah, so there are a couple of comments, so nearly 9,000 or so config options, like, yeah, good luck. Fiddling with those, although most is just modular driver stuff. The one other good thing is also I disabled Vmax and DECnet because I thought, yeah, I saw this scrolling by, it's like, yeah, YOLO, nobody has Vmax. And maybe I disabled a couple of more stuff that probably nearly nobody has. Other stuff, maybe compressed swap and FS encryption, maybe nice to have. The T2 kernels will have that next. And last but not least, the other, also the slopped stuff here, I tried to set this, didn't disable due to kernel config magic stuff. The only other nice to have thing is actually, which I overlooked and could make a difference for high core count machines, is the X2 APIC. The APIC introduced with the Pentium Pro also, I think, and in the meantime there's an X2 version and somehow this doesn't auto-enable, so this probably together with some auto-scheduler stuff. So was all this hours of testing worthless? No, it wasn't. First of all, I made this YouTube live stream, but I found a couple of things like, yeah, if you have many CPUs, not sure what the limit of APIC is, but X2 APIC is higher performance to program and allows 32-bit counter for processors, or not sure how many the regular old-fashioned APIC was. But yeah, so this might be the biggest performance change of actually using the most modern hardware. Interrupt controller stuff there, advanced programmable interrupt controller, whatever that was standing for. And plus some surrounding nice to have stuff, auto scheduler stuff. So turns out every other decade you probably should go through the 9,000 options of kernel options and see what is the best you need. And obviously benchmarking, testing and more testing, because otherwise, as you see, you try random stuff and it doesn't even change much. J. American says when he enables resizable bar 3950X can't post. I think mine posted. I think I tested that with the 3950X, which right now stands there. And with obviously the 5950X. For me it posts, although I have a super old low-end graphic card, right? Just some 560 or something. For me that posts and boots, but yeah. Maybe which graphic card do you have? Maybe that is some incompatibility with the graphic card or something. Also, I have some old garbage and for me that works. And it actually makes a difference, I think. I have this actually mapped now. RX, it says 460, this is this bloody D variant. So this is, for me, it has now 4 gigs mapped. I think previously this was 256 or 512 or whatever that was. This is AMD GPU, and it also shows here previously it said, so this just works, yeah, VRAM. I think previously I think it said here something of, here, you see RAM, even for this low-end old garbage card, previously it said here 4 gigs and like 256 M base address register something. Probably guess it doesn't make a performance difference for my use case anyway, but it's certainly nice to have fully linear addressable memory and not this bloody real mode like segmented stuff of DMAing and windowing this into there. Anyway, yeah, for this old low-end garbage stuff it actually works, but anyway, this is right now this ASUS. Also wouldn't even recommend this ASUS stuff for previous video. They don't allow BIOS updates, which is super annoying. If you flash something, it has worse memory overclocking stuff, and then thank you very much. ASUS previous videos can't even flash the previous BIOS, right? Super annoying. Anyway, so yeah, how to make your Linux, well, obviously, I hope you don't run your own Linux distribution, because as you see, it's not only super time consuming, but we have already 1,500 something, too many of those in my opinion. Probably 100 Linux distributions would be more than enough, so I hope you don't start your own one. Just use some of the major ones like Intel Clear Linux or our T2, and how to make T2 an even better Linux distribution every other week or night here with this detective work and fine-tuning. I hope you learned something. Don't forget to share, like and subscribe. Again, happy and healthy new year, and I hope to see you soon for 6 videos and code work to come.